We have Austin and Jeremy here with us today, and I'm saying welcome to PyData. And my name is Kip Sata, and I'll be happy to be hosting this session today. So I'm going to invite Jeremy and Austin to share their screen, and but before then, I'm going to introduce them. Austin is currently a machine learning engineer, manager, and also a researcher focused on NLP, natural language processing, and automated machine learning. While Jeremy also did his doctoral studies at the University of Illinois, where he worked on improving medical diagnostic techniques through computer vision and optimization techniques. Since 2017, he's been with Capital One, where he's working on machine learning optimization infrastructure, NLP, model development, such as sensitive data labeler within the DataProfiler, and the engineering design behind the open source library, DataProfiler, which they are going to talk about today in their talk. So welcome, Austin and Jeremy, and we are happy to hear your talk.
Hello, everybody. So this talk's primarily, as we mentioned, about the DataProfiler. It was developed at the University of Illinois campus offices and applied research at Capital One. Here's the main developers that we are currently working with. So it's myself, Austin, Jeremy, Grant, and Chris. Grant and Chris are currently in San Francisco. So first, let's kind of set the ground rules. What is data profiling? So it's the process of examining data available from existing information sources. So you can think of a database or a file, and collecting statistics or informative summaries about that data. And this typically helps you take actions of some kind. So our goal was to point at any file, regardless of the file type, and obtain insights for engineering, security, and data science. And then in terms of what that might look like, we might want to get things like schema, data labels, distributions, the encoding of the file, things like that. Some of the major use cases that we were tackling with this project was sensitive data detection. So you can think of like a phone number, social security number, things like that might be in a file. We need to be able to identify it. As we're a bank, that can often be pretty important. Additionally, we wanted to look at schema identification. So sometimes downstream systems, if a schema changes, will have a failure of some kind. So we're using the data profiler to basically use machine learning and statistics to identify if the schema changes, maybe columns flip, things like that. And then we're also trying to track profiles over time. So sometimes the underlying data set can change in such a way that it causes downstream failures. So we're using the data profiler to effectively identify how data sets change. So kind of what we wanted to do is make it as simple as possible. So a lot of times, if you're like a data scientist or software engineer, you spend a lot of time trying to format the data or load it in the particular way that's useful. Typically, you have kind of a standard format. So if you're using like a machine learning model, you're going to want it to be in like a similar structure every time, something like a pandas data frame. So what we want to do is load any data source with a single command, and then format it in such a way that we can do calculations on that data. So we wanted to load the data with one command, calculate the data profile with one command, and what we might calculate are things like, again, encoding, schema, data types, labels, distributions, the number of nulls. And the goal is really to do this through sampling the data as opposed to maybe doing the whole data set, and also do it in big O of n runtime, so basically one pass. The reason being is if it's something like n squared or something like that, it's going to be extremely costly as we're doing this at scale, sometimes with terabytes or petabytes of data. And then once we do that, we want to be able to display, update, or save a profile with one command. I would say in addition to that, you might want to look at maybe distributing how you calculate profiles, and we'll kind of get into what we do there. But the end result is obviously just calculating a profile and showing it to you once isn't necessarily the only thing you want to do, since we also want to track it over time. So we need to be able to save and update profiles. So we try to make the API really as simple as possible. So as you can see, if you load the data profiler, basically it's a single class that you call, and if you pass in a file name, it could be like a CSV file, an avro, really any like delimited file, parquet, JSON. You actually can retrieve what a data class out of it. So it automatically determines what that file type is, kind of regardless of the extension that's provided. It'll go into the file, sample it, and determine what the file is, and then load the data into a class that also has pandas compatible data frame. And then in addition to that, you can then pass that data class into our profiler, and you can calculate the statistics and do entity recognition, things like that. And then easily generate a report. Now the report is in JSON format. There are some graphs and some other things we can generate. We're going to kind of go into that a little bit later in the presentation. In addition to that, we also have the options of updating emerging profiles. So if you think of again, like you might have a data set split into two CSVs, for instance. So say file A, file B. You're going to want to be able to load both those data sets, profile both those data sets, and then merge them together into a single profile. So our library allows us to do that. We can also save or pickle a profile and then load it later. And then in addition to that, we also have the ability to look at the differences between profiles. So say we have two data sets, one from a month ago and one from today. We can actually load both data sets, profile both data sets, and then actually look at a difference between the two. So you can see if which data is potentially shifting. Particularly that's interesting if like the distributions in the given column are changing. For like neural networks or things like that, that can actually provide some insight as to why your model might be failing. So that's like the brief overview. What we're going to do now is actually go into Jupyter Notebooks and kind of show you guys how it works. So if you want to do it yourself and follow along, you're welcome to do that. This is on PyPy, so you can just do pip install DataProfiler full -- user. We have different versions if you want, like the machine learning components versus not having the machine learning components. Full lets you install everything at once. And then if you also want to follow along in the examples, you can do git clone, and then basically, I think I provide that in the chat. And then you just go to the examples folder. So I'm going to take a brief moment to do that, and I'm going to also post it in chat again, just in case anyone else joined. And while we do that, I'm going to answer a question by Brian. Can you do weighting in the sampling method? I don't believe we can at the moment, but if you want to add an issue, we can. You can change the amount of sampling you do. So for instance, you can say, I only want to sample 10% of the data set versus say 30% of the data set. You could do stuff like that, but I don't think you can do weighted sampling at the moment.
Right. I'd also like to kind of dig into that question a little bit, Brian, if you have a moment. In terms of weighted sampling, are you talking about labeling specifically, or are you talking about weighting different samples for getting like a statistical profile of the data set? Because that's an interesting question. And I also, while we're waiting for that, I also want to point out we didn't completely, introduce it, but at the end of the end of the training, we will go into data labeling, which is a super hot topic right now, which incorporates our natural language processing, where we're looking at either structured or unstructured text and trying to predict what that text is, whether it's something that represents someone's social security number or a phone number or what have you. And so we'll go into that in the modeling and how you guys can utilize that or develop your own models to incorporate inside the library itself.
Yep. If you guys have any questions, feel free to just put them in chat, and while I'm talking, Jeremy can answer, or vice versa. While Jeremy's talking, I can answer. So I'm going to keep going. I put in chat where you can get to the tutorial notebooks, and I'm just going to continue on. So the first topic we're actually going to discuss is what we call the data readers, or how you load the data. So if you recall, the first thing we do is we load the data, and this can be, some sort of delimited data, avro, parquet, json data. And basically the idea is you should be able to ingest ideally anything, but right now we're limited to a few different data formats. We also allow users to specify options. So you might have like a format, a header, a delimiter, the quote character, things like that you can help the system. Typically the system identifies everything pretty accurately on its own. We haven't really had any major issues, but you can also override it with the options. And then the idea is the final thing we want to do is streamline the capability. So compatibility. So what we're trying to do is load all these different data types into a single object that we can then use our profiler on. So it's a pretty challenging task. So in terms of an example, so this is actually a guide I had from COVID with my kids. So we had an activity sheet, what we would do every day at a given time. My kids are a little bit young, so if you see we're playing with Play-Doh, potty breaks, things like that. And we added @ as the delimiter symbol. We note that the actual header is on the second line of this file. And all you have to do is do DP, which we would, when we do import data profile, we import it as DP, and then we do .data and the path to the CSV. In this case, it's a @ symbol. And it formats it correctly. It identifies where the header is, it identifies the delimiter, it identifies the quote character, and basically it's able to load it in a structured way that we can then profile. And that's probably shouldn't say CSV example, but it's a delimited example. Similarly, we have a nested JSON example here where we have some metadata, and then we have a payload, and then in this case is octopus, and it's like blue ringed octopus, giant octopus, and it has different features of it. And what we do is we actually load it all into, this is broken up, but this would be a single table basically. So you'd have payload.octopus.bluering.name, and it would have all the data associated with this in a given table. So it's a single data table that's compatible with pandas that allows you to do most of the same functionality that pandas has. So that's the brief overview, and I'm going to go into the notebook and kind of go through exactly what that looks like. So if for those who are following along, you can go in DataProfiler, and then you could go to examples. And then the current one we'll be working off of is the data readers Python notebook or Jupyter notebook. So the base case for the data profiler actually is you have a single command called data, but it's a factory class which will actually load one of these different classes, right? So you have CSV data, which is actually delimited, kind of like any delimited data will be mapped into here. So you'll have CSV, TSV, I don't know what the @ symbol one would be, but basically they all get loaded into this delimited data class. You have the JSON data class, the parquet data class, avro data class, and text data class. The text data would be unstructured data. And then we actually have a different profiler for that, which we'll kind of cover later. But if none of these work, it'll be mapped to the text data class. And we'll just treat it as text data. So you want to be able to get like rows and columns, for instance, but you can still read the data. Each of these classes can be used individually. So if you just want to load something directly into the CSV data class, you can. However, if you want to use our auto detection capability, basically you could just do dp.data and then the path. And even if it has the wrong extension, it'll figure it out. So I already ran everything ahead of time just to make sure it all worked. So if you look at the kind of like the different things we're going to go through here, we have the data reader. And we're going to read a bunch of different data sets from DataProfiler/test/data. And we're going to have a few different CSV files. You might know if you want to pull up some of these, you can. So I'm going to pull up a couple real quick. So if we look at the CSV, and then we look at which one is this one? The skip header. So you can see that we don't have So this is kind of what the file looks like right here. So we don't have a header right here. There's also ones where you have partial headers. So where we'll have like blog post, state, comma. So the entire header would not be there. We also have ones where there's quotes. Basically, there's a bunch of different things that we're trying out here to kind of showcase all the different ways we do the automated detection. We also have the one where you'll have a sparse first and last and empty column. Let's see where that one is. So that one's kind of, so you'll have something that looks like this, where you'll have an empty row up top, and then you'll just have random stuff. And we want to see if this can detect whether or not this is a comma delimited file, basically. Similarly, we have parquet files that are mislabeled. Essentially, we just mislabeled as much as we could and made it as complicated as we could for the profiler. And if you run this little snippet of code right here, the second cell, you'll see that it correctly identifies all the CSV, it correctly identifies all the JSON, even if they're mislabeled, parquet, avro, and text. And then we also have this cool ability where you can just directly add URLs. So if you just throw in one of the URLs to the GitHub data, for instance, it'll automatically load for you. So this can be useful if you're just testing things out really quick. Now, in addition to that, we also have options. So typically we allow options in case the user knows their data format ahead of time, or they want to map something to a particular class. So for instance, say we have this pandas frame right here, and we know that we want to map this into the CSV data object for some reason. You can actually just say the data type.csv or data type equals CSV, and it will produce that data class for you. Similarly, you can also directly just load from the CSV data class itself and just put data equals DataFrame. There could be some reasons for this. I know, like in one of the applications, we were checking the data type to see if it was a CSV data or not, and then just logging it in the back end. So you could do it for things like that. All the options are listed on the, I want to click that, but basically on the data reader documentation. And if you're interested in the documentation, it's right over here on the GitHub page. In addition to all that, the data, we basically keep different attributes in the data class. So we'll actually identify the encoding for you. So sometimes you have UTF-8, UTF-16, ASCII. That can be useful for machine learning models or determine compatibility. So if you take this AWS Honeypot Marks Geo and you run it in through the data profile and you load it via the data class, we identify it as a CSV. We'll keep track of where the file is located, the file encoding. We'll also identify the length of the data. And then if you want to just check out the data, you can do data.data. So one of the cool things about this is basically data is the data class, and then the data would be the pandas data frame. And you could do, data.data.head, data.data.sort. And you can sort the data. There's a bunch of different things you could do with that. I'm not gonna do that right there. And then we also have other items which can check the file type. So you have is match. So this is how we're doing the internal detection, basically, of whether or not a given data set matches a class. So if we want to check if something is a delimited data type, we can do csv.data.isMatch, and it will identify it for you. So in this case, for instance, we have all the files we had before that are labeled as CSV files, but not really CSV files. And we say CSV is match or CSV data.isMatch, and we give it the file path, and it will let us know whether or not that's a CSV data. So as you can see here, all the CSV data gets labeled as such, and all the non-CSV does returns false because it's not CSV data. I'm gonna, I guess, stop here and see if we have any questions about any of this, because I know I'm just kind of going through it and no one likes being talked at. So does anyone have any questions that we can answer?
While we're also waiting on those questions, I want to put this in perspective in terms of like a story, in the sense that if you as a user have a large corpus of data, right, and you don't know what that data is, and you don't want to manually have to go through and specify how to read every single type of file, expecting them to all be curated correctly and labeled properly. That's the purpose of this class, essentially, is so that way, no matter what the file is or where it came from or what it is existing as, you can use a simple command to just load any data type. And if it's structured data, it'll load it in a format that we can read it as structured data. If it's unstructured data, we're going to load it for you in a format that can be read as unstructured. And then, of course, it just simply gets pushed into the profiler, which you're going to see next. But that's the overall intent of this. We want to be able to essentially, like, at some point, we want to be able to add, the ability to just read straight from S3. I mean, you're going to see, if you haven't seen, you're going to see that, we can just load straight from a URL at this point. So S3 is just a step away, right? And so just to be able to scan any repository of data and load it freely without having to consider how to do that has been really helpful for us.
So yeah, as someone asked, we can profile unstructured data. Yes, we can. You're not going to get all the same results, but we'll cover that a little bit later in the presentation. Yeah, so to put it into perspective, I think in addition to kind of what Jeremy was pointing out, basically one of the use cases for this is we have petabytes of data in Capital One. A lot of times people are throwing files in random S3 buckets, doing some sort of data science work. And we want to also ensure that there's no sensitive data in those files. So we need a way to basically scan all of the data all the time, anytime it lands in any kind of bucket or anything, and see if there's any sensitive data in there, but also determine like which data sets are probably more related to one another, and see like maybe one data set comes from another. So that's kind of like the upper level use case for this. We end up using it for a lot of our work though, just because it also formats things for neural networks and whatnot quite nicely. So with that in mind, I also wanted to point out you can technically do reloading. So if you have the original data and you want to reload it, and maybe reload it into like records samples per line, you could do that. So basically we allow people to format the data in different ways if you wish. That is pretty well described in the API documents, so I'm not going to go through it a ton here, but you might want to do this for things like, again, for training a neural network, things like that. You might want to format your data slightly differently, so we basically allow that option. And now we're going to dive a little bit into just the CSV data reader. So each one of these readers are going to have slightly different components, and the reason being is, as I'm sure you can imagine, loading JSON data is pretty dramatically different than loading delimited data. And one of the coolest things we think is the ability to automatically detect everything without having to worry about kind of what the underlying stuff is. So you don't have to like inspect the file yourself, at least too often. So one of the things you can do is you can load the class directly, as we kind of mentioned before. So rather than doing dp.data file path, you can do CSV data file path. And when you do that, you can use things like head. So you can basically see so this loads each of these three files and then shows you, the head of each. You could also add the options. So the CSV data class, as you can imagine, sometimes you're going to need to or maybe not sometimes, but you're going to need to potentially specify the delimiter, the quote character. Sometimes you want to say like the header is on which given line. So say you have a big CSV file and the header is actually on line 200 or row 200. You might have to specify that. We have a setting called auto, which will try to detect it. But if you have something that's really crazy, it might not be able to. And then we also determine the data format. So you can basically return things as a string or as a data frame or a record. So records were kind of described before. So it'll be something that looks kind of like this, which is just like a list. A data frame is basically a pandas data frame. And then you could also select given columns. So we use this if we want to do like subsampling, for instance. You might want to say, I only want to look at column A and B because you're using that in your neural network or your machine learning model, or you're doing some sort of linear regression, and you don't care about the rest of it. You can actually just select the given columns. Again, you'd have to know that ahead of time. So, but you could. So in this case, we're going to load the daily active sheet at with single quotes. Basically, the sheet kind of looks like this. And when we load it, we can actually, the data class, you can say data.delimiter, and it will tell you the delimiter that's in that file, and data.quote character, and that'll tell you like what quote character was detected in that file. And then you could also obviously do data.data.head. Technically, you can go ahead.
Yeah, I was going to interrupt there, Austin, because
Yep.
I think you're about to hit on that point. So one of the neat features that we also added was the ability to, if you want to delete that second data dot, we did include a wrapper. So that way, if depending on the underlying data class, you can apply the functions inherent to how the data was loaded to just our original data object. So if Austin, you want to delete one of those datas next to the head, to the left of it, yeah. And he applies that. We are basically looking at all of the, we're looking at the functions since it was loaded as a pandas data frame. We look at the functions that we could apply to the pandas data frame instead. And if you want to apply that, or you want to do slicing or indexing or so forth to that data set via the functions, we allow you to do that directly. So you don't have to call data.data every time. You can apply the functions provided, it's not something we've technically overridden with our data class.
Yep. Similarly, you can actually set the options. So we just set the same options because that's what it's supposed to be. But you can manually set the options as well. So this is useful if we have a file that for some reason can't be loaded. Currently our thing seems to load, or the system seems to load relatively well. So we don't really have too many times like the auto fails. But if it, for some reason it does, you can switch stuff out. And then here's a one where we intentionally cause a failure with incorrect options. So take the same file and we say that the delimiter is a comma and the quote character is a, just a double quote. If you try to load the data, you're going to get something that looks kind of like this. And it'll say when data type is set to CSV, it fell over to text data. So basically, what ends up happening is because those options are being set in that particular way, I believe, can we do this, Jeremy? It'll fail over to the text, basically. So, essentially we gave it these options. We said, this is the delimiter and this is the quote character. The system failed because it's not using the correct data. And so you're going to end up getting basically different data set. There you go. So it basically fails over to text. And if you want to see kind of what it looks like, you can still technically access all the data, but it's just not in a formatted way. In addition to kind of that stuff, does anyone have any questions? All right. I'm going to continue on then. So in addition to kind of that, those options, you can also set the header. So some of the more complicated files we have in our test set, one looks like this. So it's author Austin Walter, then it has a couple like lines of description, followed by the actual header. So detecting that is a little bit difficult, but the system's able to handle it in this particular case. So essentially it goes through and identifies the first time it starts seeing a pattern, and it sees a pattern with the commas and the 3 columns. So it's able to pick that up and skip the first few. And You could also intentionally set the header. So I intentionally set it to the wrong row. So I put it as row 2. And you can see that you have this description up here, which is what it ends up grabbing, when in reality it's supposed to start down below. So it looks at each of these as a single column at that point. Let's see what else. So, and this is where we kind of covered the differences between the data formats. So the data formats will load. So the data frame basically loads everything as a pandas data frame. We also have records. So in terms of records, they will load everything as you can do record samples per line. So that's how many rows are combined into a single line. This is useful if you're doing something like particularly for neural network training, where you might want to take just like maximize your throughput through a GPU, for instance. So you're going to want to basically flatten part of your data set. So as you can see, we take the diamonds.csv. Here's the first few lines of that. And then we can actually flatten it to the record samples per line. So just for the heck of it, I'm going to do 2. And you can see that it'll generate, should generate 2 there. Yeah. So in terms of kind of like it's hard to see with the thing, but basically it takes these 2 rows and we'll flatten them into a single entry, if that makes sense. So you have row 1/n, row 2, then you have row 3/n, row 4, and so on. So then you can basically feed that into your GPU. Is the primary use case for it, and you can have the entire kind of like GPU maximized. And I think we're nearing the end of this, but basically the next one is you can also select columns. So say we try to load the AWS Honeypot Marks geo.csv dataset, which has a bunch of different columns in it. So we have longitude, latitude, owner, comment, datetime, host, source, things like that. It's basically just logs for routing. Say we only want to select the datetime, host, and source. You just say selected columns, and then you can pass it into the data along with the file path. And you can get the given columns. So this is kind of the end of this particular section. For those that are curious, who are just joining us, who want to follow along, here's the chat. We are using this repository, and we are going through the different examples, the example notebooks. If you want to install it yourself, you can just do pip install DataProfiler full. Be easy on everybody. Cool. So does anyone have any questions on the data reader section that wants to speak up, or you can post in chat and I'll read them aloud.
If you are on a Mac using ZSH, you will have to put quotes around DataProfiler all the way to the end for full when you use the square brackets, just so you know.
Alrighty. Jeremy, do you want to take over from here?
Yep, I am good to go. All right. I think, Austin, you can see the screen. I assume if you can see it, everyone else can.
Yep.
Yeah. So now we get kind of a little bit more fun. Obviously, data reading is really important, and be able to automate that system opens up a lot of avenues, specifically for either profiling or data labeling. Just like I said before, to be able to scan a repository with no known idea of what's inside of it and to get information out can be critical. So we're going to go over the specific aspects of the profiling library. First component is just generating. So if we focus on structured data, we're going to generate information about each column within the data set. We're going to do simple statistics like min, max, mean, histogram. We're going to get more complicated by determining whether like the data set's categorical, is there order to the data set, like ascending, descending. We're going to look at some more complicated statistical properties like Gini impurity or unlikability. So we've added a lot of components, and a lot of that has been feedback from our users and what they're looking for. And some of the other like neat aspects of it that was kind of slow or introduced slyly was the fact, we can do something like profiler differences, where you can take a data set and take a second one and try and figure out what's different between them. Like why is, if you're training on, if you're talking about neural networks or models, if you're training on one data set and then you're doing validation with a second data set because you've split it, but the results are really off, you could, take the differences between the profiles of the data sets to try and, inspect or understand what's happening or what are the differences or changes between that data sets that might be impacting your model. Or for instance, you've developed an API on a specific data set and you're getting a new data set and you're logging that information, and you want to know, why is the API not working as expected? And you can look at, obviously the difference between, how you spec'd out your API in one data set and then decide, and then what you're actually getting, or that can just give you information of how you need to update your API. And so we generate column level statistics in structured, we generate global statistics in structured, and then we want to give everyone an easy way to understand what's in it. So we output a report. We want to at some point make it an HTML report. Right now it's basically a JSON report that's printed out, but also we allow a graphing feature. So this is what the report looks like. And just in case, I'm going to pull up my chat in case anyone asks questions while we're going through this. Right. So this is what a structured report looks like. And this is not even the full list of elements that we have within our data stats. So we have a component that's global stats. We have a component that's data stats, and you'll see something that calls times. Times essentially, we want to record how long it takes each component. So that way, I'll talk about options. Once again, readers have options, profilers have options, reports have options. We want to give the user as much customizability as they can for when they're using this product. But we do that because, especially giving information about the times, is because not every user needs every component or every statistic given by the library. And we want to give the users the flexibility to turn that stuff on or off, and the ability to reduce the computational cost of each aspect of the library if they don't need something. Like many users maybe just need labeling, and they want to know what the labels of each column are in the data set. Or maybe they just want to know simple features or like a histogram of the data set. And so they can turn off everything else if they want to. And so we tried to make that really simple with our options, but always improving, right? You never can do it best, the first couple of times, always iterating on that. And so I kind of just talked about options. You can turn stuff on or off. And then in that report, you're going to get a more simplified view of what's going on. And because I don't want to spend too much time on slides, jump straight into the demo. Once again, this is our repo, github.com/1/DataProfiler. We'll be in examples, and we're going to go through the structured profiler. And then after that, we'll get into the unstructured profiler too. And again, if anyone has questions, please put that in chat or chime in. Happy to answer that while we go through. Austin is happy to answer that on the fly. So please don't hesitate to let us know what's going on. Okay. So structured profiling, I'm going to gloss over this just because we know, we went through the slides. We talked a little about what this means. Some stuff we didn't talk about was like the options. When we do our reports like this, we give the users different, abilities to make the output more readable, like in a terminal, or the output more readable in terms of like limiting all like maybe unnecessary features by making things a bit more compact. And then obviously we want everything to be serializable so that someone can save the report and open it up elsewhere. So we save it as a JSON if that's desirable. And then In some situations, like saving to a database, for instance, that database may not be able to take a nested structure. So we do have the ability to flatten the information that comes out of this report so that can be saved accordingly. So I'm going to jump right in here. I'm just going to run this. And hopefully some of this doesn't take too long. Basically, just importing the library as you would expect. We've already learned how easy it is to load data. So all I did here was load the CSV data set for the AWS honeypot, one command to profile that data set, one command to report it, and then I can print it out. And so obviously we have logging again. We had a user ask us to disable that. So if you want to, and the printout of text gets is not something you desire, we do have the ability to turn off the logging features of the library. So like you see here, we have global stats here. It tells us how many samples were in the data set, how many columns there are, the row count, very simple basic stuff. We're looking at hashing between rows to determine whether a row itself is unique across the whole data set, how many duplicate rows there are if we were to find that. Tell you about the file type that was loaded, what the file contents looks like in terms of its encoding. We have information like this is NaN probably because of just what the data set was. It wasn't able to do a chi-squared matrix, and that's okay. We give you the schema of the data set. So we are able at this point to handle duplicate columns. So if you have a data set that you load that has two names that are potentially date time, we will give you a list of the indices of where those date time columns exist, or where that label or that header for that column exists. So we are able to handle duplicate columns, which is could be a complicated feature otherwise if you're not expecting that. Scroll past that. So obviously it tells you how long it took to do those row statistics. And then we get a little bit more interesting information here. So we get a data label that's using our data labeler, and it's looking at this column date time and determined there's date times in here. It also determined there may be floats that exist somewhere in this data set. And so that could just be based on the representation. So we might have different representations of date time and these are the samples that it pulled out from this data set. So it can give you a subsample of that data set to look at. If you're interested in that information, it'll tell you the min, the max for date time. And it does this for all these different types of data formats. What's really cool for date time is if you do have a mixture of formats, it will give you an entire list of those formats and give you that output. So we are kind of like the rest of our library. We try and automate all the processes, right? So we try and automatically determine the date time format that exists in each column. Obviously, we can't cover them all because it's too expansive, but we do have a list of maybe like 15 to 20 formats of date time. I'd have to look exactly to remember what it is, but to give that output essentially. And then of course, so data type representation is basically saying we look at like the primitive data types within Python, date time, int, float, string. We don't do like objects. Essentially, we would probably characterize that in string is our case to be able to profile it itself. But we're going to tell you what it could be represented as. So it's basically saying this data set could not be represented as an integer. It could not be represented as a float. We can convert it, all of the pieces, all the elements in this row to a date time, and we can obviously, anything can be converted to a string ultimately. So that's always going to be one. But if it's any one of these, we're going to let you know essentially. And so we do this for all of the different columns within the data set. So we just have a full list on top of that global information that we've given you. And I don't want to harp too much on this because we could spend hours investigating the report itself, but I want to keep going just to show you more aspects of the library. I may have reran that, but Pretty is just trying to make it a little bit more user-friendly to read. So like aspects where potentially you have a super large matrix, obviously this isn't that big, we're going to shorten the information around that. You can see here just a little side note here, you can see we loaded it as a pandas data frame up here, and it's going to tell you actually it wasn't from a file. It was actually from a class within Python, and it was a pandas data frame. So we're able to give you that information. But yeah, pretty is essentially just trying to make the information a bit more compact and readable within a terminal. Profiler type. So I talked about the fact that you can do structured and unstructured. Obviously, the data set we're working with is structured data, but it's possible if you have a structured data set, maybe you don't want to read it as a structured data set and you want to read it as unstructured. So we give the user the option to read those files if they want to, or to profile those files with whatever mechanism they choose to. So if they want to profile it as an unstructured data set, you could technically flip this profiler type to unstructured and do so. So this is just going to give us the same information out. So we don't need to dive into that too much. But like I also said before, profiler options. So essentially we're able to customize the report or customize the information. In this case, you would generate essentially a class called profiler options, and then you can set whether those features are enabled or disabled within the class itself. Some of these will have more complex settings that you can have. For instance, we will go into how to configure and set up a data labeler for your profiler rather than using the default data labeler. Ultimately, we want you to be able to customize it however you need to. If data labeling is super expensive, you could turn it off, or in this case, we want to limit the data labeler to a maximum sample size. So like for labeling, it is computationally expensive, so we don't want to waste all our processing if we have a file that's, you know, hundreds of megabytes or a gigabyte sized file. So we're going to allow you to say, instead of sampling the whole file or sampling we essentially just want to give you the customizability to, you know, give whatever computing cost or set whatever computing cost you want to when you're doing profiling, so that it doesn't take an extremely long time. And so we can do that as we've done here. And so this is a different data set. The Diamond data set had around almost 11,000 samples that were found in the file, 10 columns. Oh, sorry, excuse me, samples. I should say we subsampled the data set because the user didn't specify otherwise. Once it gets above a certain size, we'll subsample it by 20%. And so the original data set had almost 54,000 rows, and we subsampled it to around 11,000. We did find we did find duplicate rows within this data set, and we marked that out here. And then we just have other interesting bits of information that you can look at. But the interesting part is we turned off different aspects of the library, like the histogram or int profiling. So none of these columns ultimately would be profiled as an integer or get integer statistics. Anything that looks like an integer would ultimately get profiled as a float instead. And now we that stuff is, you know, like, okay, you know, this seems pretty straightforward, but this is where it's going to get a little bit more exciting. Let's say your data set's really large, right? Or you don't have all the data set at once. Maybe you're getting your data set in as a stream. We allow you to update your profile on demand as you need to. So you can grab part of your data set if it's really big, or if it's coming into the stream, sample by sample, you can update that profile and it will update the information. So all of the statistics that we try to provide you, we've tried to implement these algorithms in a way that they handle batch profiling or online. We're trying to use online algorithms essentially. So that way the statistics are as accurate as possible, despite you not necessarily providing it the whole data set at one time. And so here, all we did was load one data set, we profiled it, we grabbed a new data set, and then all we did was call update the profile with that new data set. And so we could look at the new profile essentially, describing it, which is a combination of both of these data sets. And so here's what one data set looks like, here's what the other one looked like. And you can see the combination of them. We now have 18 samples. Both of them had 3 columns. And of course, there has to be some schema matching, right? Like we can't just update a profile if the schemas are not congruent. That is one stipulation on the profile when you're doing when you are updating it. But we are able to do it, which is really cool. And just a simple extension of updating the profile, being able to update in batches, is merging it, right? So we've made this really simple for you as well. You can take that same data set, instead of updating the profile, it's just a simple addition. And so it's as opposed to altering the original profile of either one, you could now essentially do like a map reduce, where you could split a data set into a ton of tiny components and then just reduce it back together into the original profile. And so we can look at that and we could see we're getting the same results out essentially, and the same information out that we would if we updated the profile, or the same information we'd get essentially if we just loaded both of those data sets together. And then another final cool part about this, and I had harped on this a little bit, was differences in data. For us as modelers, it's really important for us to be able to understand what's happening in the data sets we're training a model with, or understanding the information about the data sets we're validating a model with. So that's what we're trying to do here. We're trying to give us insight essentially into what's happening in the original data set that we trained with, what's happening in the data set that we're doing our validation. And if there's an issue between them, if we're not getting the results we're expecting in that validation data set, we can use these differences essentially to tease that information out. We can bring that to light to see what's going on. And so it's going to go through all the different aspects of all these different statistics that we described in the library. And it's going to talk, it's going to give you simple information about unchanged or changed. But it's also going to go into a little bit more detail depending on what the information it's describing. I'm going to scroll past some of this to try and get to that. If it's numerical columns, right, we're going to give you a t-test. We're going to tell you how similar each column, provided the column, once again, we require schema matching for this, but we're going to tell you, column in data set 1 versus column in data set 2. What is the likelihood that, they're drawn from the same distribution, right? We have statistics. I'm trying to see if I can scroll here to find some. We'll look at the min and the mean and the median. And so I guess the data set that we're dealing with was extremely similar. So that's why we're getting everything to be pretty much unchanged. Could have chosen a data set that was a bit more different, so it'd be more visible to see what's going on. But ultimately, we're going to give you those changes of information about the data set so you can, draw analysis on what might be happening. Or if you have a data set that's coming in as a string, right? You could log profiles of each of these data sets over time to see how your data is drifting and how that data drift could be essentially affecting your model in the long run. And hopefully at some point, based on the way the data is drifting, make a prediction whether the model needs to be updated or changed over time, or whether the model will still perform well based on the alteration to the data set over time. And so you can track those changes. And then the last cool feature that we give you, besides saving and loading a profile, of course, we wanted to give users the ability directly to be able to graph information. And this part of the library is still being built out. Obviously, we love contributors. But the first plot here is a missing values matrix. And so it's basically just a bar chart. We're going to give you, we're going to show you where in the data set null values existed. You can see here we have 2 different types of null types. This green one only existed in one location, and it's just a bunch of spaces. You can see it happen in the comment section. No surprise there. But where there's blue here, data is filled in. Where there's orange, we can see it's just empty. It's just an empty a null, just nothing, no information there. But it's nice because visually you can see the comparison between columns to see, what data is going to be coming in similarly, or what data maybe is a duplicate column of the other data set. And so we can make those investigations and potentially even determine, if, between locale and the locale abbreviation here, we could see if, looking at this, maybe there's some alteration or human error that occurred based on where we see those null values in existence. And then, of course, histograms are really important. So any numerical column that we find within the data set, we will automatically give you a histogram if you were to call our apply histogram. We do allow you for each of these to specify what columns to utilize. When you generate these plots, you can put those plots into a figure that you've already created. That's awesome, Roger. Roger just said, already shared my first report with the team. Solid tool. We're going to be getting good mileage out of it. I really hope so. Please continue to give us feedback and report any issues you find. We are active on this project and want to stay active and love contributors. So really happy to hear that information. That's why we built it and open sourced it, because we see the good in this product and we want to make sure we can give that to everyone else as well. It's a labor of love for sure. Yeah, so generated, you can generate these graphs and you can save the graphs or plot them. And ultimately we want to coalesce this all, both the JSON report and these figures. We want to be able to put them into an HTML report. So if you're getting excited about this and you want to contribute, please do. We'd love to get you started and help us out on this product, because we think it can go, really far in terms of the utility. And then the final main feature here, saving and loading a profile, right? Just generating the report is great, but maybe you want to hold that snapshot or move that snapshot around, and you want to update that snapshot at a later time. So of course, saving the profile and loading the profile is extremely important. So we give you that feature as well, ultimately. And so this is just saving it and reloading it, just to show you that it's giving you the exact same stuff as it did originally. I don't know if we want to look at all this text here. That's not as super exciting, but the feature's there. So you can share profiles. In fact, something that we've thought about is having a data zoo with profiles, right? So a data scientist can go through and see what data sets and the information about the data sets without having to go and do the investigation themselves. So we're working on that. Austin, do you want to answer? Oh, Austin is on top of it. Thank you. So that concludes the structured profile. We're about to get into unstructured at the moment. Obviously, we're getting some questions. Would love to field more. We only have 30 minutes and there's still the hot topic of data labeling left. And I really want to get into that because it's super exciting. But definitely want to field questions while we keep going. Okay. All right. So keep putting the questions in chat while we're going. Unstructured profile report. Ultimately here, this is a newer aspect of the library as well. We've really built out the structured aspect of it. We would love help and insight. So if you have statistics that you're interested in unstructured profiling outside of what we've done, please provide feedback, please contribute. We would love to have some help on this. But it's a similar idea, right? We have global stats information about the entire file, and then we go into a little bit more nitty-gritty detail about the text itself. So we talk about entities, we talk about the characters that exist, the words that we find based on separators that were chosen. Separators meaning like spaces or commas or stuff like that. So trying to chunk the words together to give you information about the words that exist. And then, of course, data labeling, which is probably the hottest part of unstructured profiling, is to know what sort of text exists within there. And our focus, of course, has been on sensitive data. So we're going to jump into this real quick. That's the repo. So I'm going to hop over to the unstructured. Oh, it's probably at the top. Give me 1 second. Thank you. So unstructured profilers, similar thing that we're hitting on. So I'm just going to run this and load this real quick. We grabbed a random discussion from Reddit. And all we're going to do is grab that discussion, and this is going to give you a high level information about what we find in that. So we talk about, when we talk about entities and data labeling, we're talking about the types of text our natural language processing model is finding within it. Unknown is just basically saying it's generic text. We don't care about it. It's like, they could be stop words. It could just, it's basically the filler text that's not providing the information that, is necessary. It could be just random adjectives and stuff like that. But we tell you about integers, ordinal information. Some of this is non-sensitive that we're looking at right now. Quantity, so we're finding, someone's talking about, maybe they're talking about some recipe or something. But we found obviously people's names in here. We found addresses within this, dates, US dates. BAN stands for bank account number. I'm not 100% positive that would be accurate. Bank account number is actually it's a very wide field of numbers. So it's likely to assume that those would be false positives. But it's possible also to exist. Obviously, URLs, people are making lots of links in with Reddit, email addresses, and we have a lot more labels that we can look at. And so we identify those, we talk about it. And if currently in the unstructured, we won't tell you the location, but if you use the labeler directly, we will tell you where in that text that information exists, which is really cool. And then it's going to talk about, I'm going to scroll down a little bit. It's giving you a bunch of information, telling you how long it took to do the processing. It'll give you all the character information that it found within there. So if you need to build, like for your unstructured model, if you need to build an encoder, we're going to try and help you do that essentially. Obviously, there are programs that exist that help you do that automatically. We're just another tool to give you that information as well. So like I said before, you can load a CSV and just switch it to unstructured and read that data set as unstructured as opposed to a structured data set. So we're giving you that option to read the data however you want to. Of course, you don't have to use the dp.profiler. You could technically use dp.unstructured profiler as well and not have to specify the profiler type. But this just gives you direct access to the original profiler to give you that utility. And of course, you can specify the report out essentially, and it's going to give you the same information about what we see. And of course, computational cost is important to us. So we're going to give you the same options. You can change the stop words that it finds in here. So you can alter essentially what it's removing from its word list that it's grabbing. So it's going to try and grab all the words and give you the count of words within it, especially if you're trying to do some sort of tokenization for your model. And then we want to apply the same principles, the cool principle of updating your profile, right? We want you to be able to, stream your data in batches. We want, if it's an online profile, you're getting text as it comes in, like through an API log, and you want to track the information that's going through your when logging your API. We want that ability to be there for you, so that way it's not a profile that's one and done. It's a profile that can grow. And you're going to see we can save that profile and load it later. So, and you can update that profile continuously as you need to. And so it's just getting all that information here. Again, merging profiles. If we can do batches, why can't we do merge? Super large text file, break it into pieces if you want to. Get all the different profiles, simple addition here to reduce that information into a single profile without altering the original profiles. We're going to give you that ability, which is really cool. And then, like I said, I want to get into labeling. So I'm kind of going through this really quickly because I know we don't have as much time, but we do give you, like I said, the ability to save and load profiles. And I don't want to go into this too much. I think it's, obvious what we're trying to do here: load the data, profile it, save it, reload it, give us a printout. This means you could send the profile to someone else, or you could send the report if you want in a serialized form. Whatever you need to do, we just want to give you that flexibility to work with that information here. Yeah. Are there any questions that we have on structured or unstructured profiling that we can get into? I know Austin's been answering them as we go, but I'd love to field more as we continue on. Is that a question? I heard someone speak up for a second. Okay. I will continue on. So this is going to be my favorite part of the library. It's really neat. We've tried to basically abstract the library in a way where any user can incorporate any preprocessor they want to handle text, to feed into a model. They can swap out the model however they want to. If they have their own model, they can swap their own model in as long as they set up the correct preprocessor to handle the text. You can also handle post-processing as well. That's swappable. So these are their three main components. Definitely can build on this to even make it more modular. But we want all of our components of our library to be modular so you can swap out anything as you need to. And what we're going to see here is like the original, the other aspects of the library, we try to make this super simple. Load your data set, label your data set, load your data set, load a labeler, and just get predictions and print the predictions. And so you can see here, we're working with a structured data set. We got a CSV here. And presumably it looks like this table here. And the labeler is going to give you an output of each of the columns, essentially, or each of the points within this data set, and tell you whether, you know, it looks like a time, or it looks like someone's phone number, or it looks like a social security number. So we're going to give that information to you. And again, same thing for unstructured. And this is the neat part, is since we built our model, we have a paper on this. So if you're really interested in that, we can certainly link that to you. We've built an incredible synthetic data generator to help train this model. Our synthetic repository to generate this model, essentially. And it allows us, because we're doing character level identification, we can identify where in the text, even potentially if it was, you know, put within a word itself, it's possible for us to technically identify entities or labels within that text. And so you can see here, we're pulling out things like email or date or URL in this example, and it will tell you the location of where it is in that text. We allow you to bring your own labels and your own data. So let's say you don't want to bring your own model and you don't want to handle any pre-processing, and you just like what we have, fine. We're going to give you the ability to transfer learn, take your data set with our original learning, or the original model that we build, and learn on top of that to help speed up your training. So maybe you could use less data to get that, or you can reset the weights and start from scratch, whatever you want to. And of course, we give you the customizability to, you know, affect whether, you know, change the number of epochs, validation split, et cetera. And of course, we want you to be able to save and share the labeler, right? So if you build a labeler and you want to either reuse it in the future or share it with someone else to utilize, like, let's go with this scenario, right? I'm in company A, I have a data set that I can't share with company B. So, but I could share the model potentially. So I train my labeler on data set that I can't share, but the other company needs to be able to identify that data if it were to exist. So I can create a labeler as company A, save that labeler, and share it with company B. So that way they can still identify it without actually sharing the original data sets. Into the demo. I'll jump here. Right, so preprocessor model, post-processor. Start off, of course, with structured prediction. We'll look at what that originally looks like. It's just a tabular data set with a bunch of pseudo-random information. And what we see here is it's going to identify the labels of each of the columns. And so we can see this is just a list of all the labels that we currently identify. And this is how we map those labels to indexes based on what the model is specifying. It's not super important, but we can ultimately get this list of predictions of what it ultimately thinks the original data set is, how it's represented. So representing, an integer, it didn't recognize, like we don't do companies or places essentially. So it's saying, it's unknown generic text. It represented this zip as an integer potentially. And there are cases where it'll represent it either as an integer or an address, depending on the data set we're working with. So it might give you that information. And predictions, of course, they're going to give you the highest confidence, but you could technically look at the confidence of the model with each prediction. So it's possible, like for instance, the zip code, right? The model is actually probably saying underneath, this looks like both an integer and it looks like an address. But it's more of it looked like just an integer itself. And so that's why it gave the confidence of that a little bit higher. But you could look at that information and say, it actually might be both of these. And that's how you could potentially determine its zip code. And so you can see those confidences. And then I'm gonna just have this little helper function to help us make things a little bit cleaner when we make it more readable. Let this model do some processing. And so we can see here, the profiler itself is just doing labeling, and you can find that within the data set. And so it's labeling, and this is we just pulled out a sample. This is integer, this is unknown. It's grabbing some integers here. And it's obviously notating this as URL. And some of this is really easy in terms of you could build a regex to do this, but there's more complicated things like addresses or people's names, or the overlaps you can end up having in social security numbers and other numbers that you might have that driver's license and social security number, there's overlap between those. And so making the determination between those, our model is, that's the reason we built something that's neural network based or ML based, is to be able to help with those predictions that are a bit more complicated than something that's regex based, where you have to know and institute the rules which may or may not be 100% correct. And so we can do the same thing here with this unstructured prediction. We can load an unstructured labeler. We can predict data with that text. This is just giving you a character output. So it's telling you each character it found within that text, what entity it's mapping to. So when I talked about that label mapping, which was just based a dictionary of keys and values, where the key was the label name and the value was the integer. This is essentially what we do to determine we can map these integers technically back out to tell you what the representation, where it existed in this text. And so I'm going to do that real quick. And then here's just a subset. You can see it's not 100%. And so things like carrots, we might have to do a little bit extra post-processing, but it's able to grab email addresses, or it's able to grab, date time. It is able to grab, someone's name here. It's able to grab, I guess we got another name here. But this is just a subset, it's someone's phone number, essentially. These seem generically obvious, but there is many cases where the data is not represented in the format that we'd expect it to come in as. And the whole point of this model is to be able to have that adaptability to handle those cases. And of course, like we said, we want you to be able to train the labeler from scratch. So what we can do here essentially is bring in our own data set, right? And then use this function dp.trainStructuredLabeler. We can specify the labeler. It's going to grab this data set and assume that the column names are the labels that you want them to be, specify which one you want it to ultimately default as, train it for 10 epochs, and then you can predict with that. Or what you can do is in the profiler, I had mentioned this before, but the options, we give you the option to say, when I'm doing profiling, I want to use this labeler I just created instead and profile with that. So any data set you put into there, it's now going to use your new labels. Now, I didn't do the greatest training here, right? So it's not going to be perfectly ideal, but you can see it's doing, it is able to now make predictions using your new labels that you chose. Of course, the testing and the test data set is almost exact to the training data set. So the model is probably going to do very well. So this is kind of a very simple rudimentary example, but the thing is we're giving you that ability to swap out those labels. We give you also the ability to extend labels. Let's say you like our labels that we have, you can add labels to the model, and you just need to continue training with that. As you train with new data, of course, it could, reduce the accuracy of the labels that already exist potentially if you're not also training with that data as well. But you can bring in your own data to add new labels if you want to. This is just another way of changing the options. Is you can, if it's saved to a directory as opposed to using the object in memory, you could specify the path to the label or to the model. So if someone shares with you the model, right, you can then just specify the path and load it that way if you want to. We talked about transfer learning. That's where we just add labels onto the existing. And so we're just going to add these new labels here and train the data set with those extra labels that we've just added in here. And you can see it's not doing the greatest. Of course, not using a lot of data. That's not intent of this demo is to show you a perfect result here. All right, the intent of this demo is to show you can do this and you can get your model to a state where it's making those predictions. I guess the results here didn't have the original data set, so that didn't work out, unfortunately. Oh, wait, here they are. I just had to scroll. Look at that. So original data set had, we had those three and we did evaluation on that. And you can see, it's not performing the greatest. We didn't train very much. So in the original model was trained on hundreds of thousands of samples. So you would need a lot more samples to be able to get to that point. But it is possible to just add labels onto the end of the existing labeler and be able to use those predictions as well as the ones with your new labels as well. And of course, saving it and loading it so you can share labelers. And then you can completely build a labeler from the ground up. You can swap out the preprocessors, like I said. You can write your own preprocessor. You can add to our library and include more preprocessors. We obviously have default ones. We have a whole regex one. There is a full example in this notebook where you can build a regex labeler from scratch. So add your own regex if you want to use your own regex model and use that inside of the profiler. We give you that ability. But you can swap out the preprocessor. You can swap out the model for whatever you want, swap out the post-processor. And then we have a rudimentary ability to be able to check the pipeline just to do a validation, and it would give you an assertion error if there was a problem. The other neat feature is when you're dealing with our labeler, we give you help functions, right? We want you to know what parameters you can alter in the model or what parameters you can alter in the preprocessor or post-processor. So that way you can set up the options just like anything else, like the profiler options, like the data reader options. We want the customizability there for you to be able to do that. And so that's ultimately what we're doing here. We've basically built this 3-component library. It's a data reader, it's a profiler, and it's a labeler. All of them abstracted enough from each other that you could use each one independently. Obviously, you need to load the data in somehow. So hopefully use our data class before you put it into the labeler or before you put it into the profiler. But you can take these components and harvest them and reuse them however you want to, or take these components and dice them up and use your own components that you have. Ultimately, we built this library for us, but also for others because we see the value in it. I don't think we're going to have enough time for the final demo because I would love to field more questions. But ultimately, like I said, you have the ability to create your own model, and that's all this is doing, just so you can see. We're taking a character level LSTM model, specifying all the parameters, telling it how to validate, basically, so that the validate parameters is essentially just, telling the model or telling the class essentially, what sort of parameters, like what the format has to be in to be able to accept them. But how to construct the model, this is where you're actually putting in the model. And this is one way to do it. We want to also add like a class, like if you already built a model in in TensorFlow, just to be, not to even have to write the class. We want you to be able to eventually just to be able to load that model itself directly into a class, like a model loading labeler. That way you can just load that in and directly insert it for prediction however you want to. Ultimately, like I said, you can create a new model, add it in, add your pre and post processors, specify the options, turn things on or off, and make predictions with that. But yeah, I know I jumped through that really quickly. We have 9 minutes for questions. This is just the example of showing you how to create that, but I'm going to pause there.
From Brian, is there a profile to SQL schema sort of thing? We don't have that at the moment, but if you want to throw up a GitHub issue, that's probably doable.
It's a very valid add. Like I said, we do convert to a serializable JSON format, so it'd be very easy to just dump that into a database if need be.
I know we have within Capital One someone they're tracking this stuff, but I think they're dumping it into an SQL database. But they wrote their own functions for that.
Yeah.
When you compare profiles, is it possible to set the sensitivity? Also switch between relative and absolute difference. I don't believe we can set the sensitivity at the moment, nor can we switch the relative versus absolute difference. But that is a good question. So you're talking about like percent differences, I'm assuming.
So one thing I would say about this is currently we don't, we're basically giving you values out in terms of the differences. We're not acting currently. This is something we also want to add to the library, acting as a validator to say this was a big enough difference. So typically we'll say unchanged or tell you the value it is changed by. I'm curious the thoughts on absolute differences and what fields you're thinking about and what stats you would be thinking about in terms of absolute differences. When we do things like t-tests, we try and give you all the information like degrees of freedom that we determine and stuff like that. So that way, if you need to redo the calculation yourself or use a different confidence interval to determine whether it's statistically significant, you can do that. We're just giving you, we're just trying to give you the information and data so that way you can make that final decision and be the validator yourself. Not to say we don't want to become a validator and have that as a component of our library. It's a very good question. Thank you, Erica.
Lucas asked, how do you plan to scale out of memory data sets? So right now we actually, we do like have the way it's kind of deployed internally is it spins up in a bunch of Docker containers and then loads the data in segments, and then it'll merge the profiles together at the end. Right. So that's kind of the way we built it. So you can scale at will, save the profiles at some location, wait till all the jobs are done, and then merge them. I'll stay on for another few minutes, but I just want to say I really appreciate everybody who attended. Thank you for your time.